Okay, this is lesson 2.11, 2.11, verbal models of expression, equations, and inequalities. So as you can see, there's a lot of terminology which represents each of our four operations. So with addition, subtraction, multiplication, and division. So this is a great sheet to even take a picture of, take a screenshot with your phone, to just help you remember some of the words we use to represent things like addition. Like the word plus, I think is pretty obvious. Sum is one that sometimes catches us off guard. That's when we're going to add things together. Increased by also means to add. We find the total of something, or you typically finding the sum of that. More than, and then I think added to is an obvious one. All right, so with subtraction, those are probably the lesser known. I think minus is a pretty common term. If you're finding the difference of something, that means subtraction. If something is decreased by something, that typically means to subtract. And then these three, fewer than, or if it has so many less than, we're probably going to subtract, or subtracted from. And a few others with multiplication. Times, I think, is probably the most common one. The answer you get when you multiply is called the product. So sometimes you'll see that word product, and you need to know that means you're going to multiply because it's the answer for multiplication. Multiplied by is pretty obvious. Of is one that sometimes gets us because of is such a small little word. When you see that in the middle of a story problem, it's a little bit difficult to find sometimes. Twice is when we multiply something by 2. If we square something, an example would be to take 4 times 4 and we get 16. So we're actually squaring it. Sometimes it even looks like this with an exponent. Cubed means we're going to take that same number and we're going to do that 3 times. So it'd be the same thing as saying 4 to the third. And 4 times 4 times 4 is actually 64. So definitely need to know the difference between squared and cubed. And our final for division, divided by, is pretty obvious. Quotient is that answer we get when we divide. So the quotient, I'm just going to put a Q here. Typically when you're doing long division, that quotient should be at the top. And another one, if you're separating something in equal parts, they'll sometimes ask you to do that, and that's also going to mean division. Okay, so let's move on. And we're going to look at some of these individually. So if I see this variable expression that looks like this, one way to show that with a verbal phrase is to maybe say something like a number increased by 9. Or you could say a number added to 9. So there's several different ways you can express that. So this next one, the difference between a number and 21. So if we were to write that as a variable expression, it might look like that, where n or whatever letter you use as your variable would have to come first. And then we're finding the difference between that and 21. So we write it as n minus 21. All right, our next one, the product of 6 and a number. A way to show that product means to multiply. So we could say 6n. We could even write that as 6 times n. In algebra, though, we try to start writing it like this because the fewer signs we can take out, the better off we're going to be. We can shorten things up a little bit. The quotient of 48 and n, that's division, and that one is already shown here. So right here, this means division, and it's a good tactic to try to write it just like this instead of writing it like this. And you'll actually start to see why as we get some longer equations involved. The 48 over n option is going to work a lot better. So the next one is this one right here, 1/3 of a number. And if we do 1/3 of a number, that's actually going to look like this. So we just take 1/3 and we multiply it times something. So we're going to put 1/3 and then n will sit right beside that. So let's go on to the next screen. With inequalities, we have similar things. This represents greater than. It also represents more than. So if you see the words more than, it really means greater than. Less than looks like the letter L. So if that helps you remember that that's less than, it also can mean fewer than. Greater than or equal to, this catches people off guard all the time because when you say at least, if you think about it, if I said you had at least 20 cookies, that means you could have 20, but you could also have a lot more than that. So when we say at least, it means greater than or equal to that amount. And then another phrase you can look at is no less than. Less than or equal to, I think we're most used to that. The one we struggle with a little bit is at most. So if I said you have at most 20 cookies, that's the largest amount you can have. So it's either going to be less than or equal to that amount. And then also no more than. That also means less than or equal to. All right, so here's some phrases, and then I'm going to show you what it's going to look like as an algebraic expression or even an equality. So a number squared, we typically write it like that. And you don't have to use n, but that's the most common thing that we use in algebra when we don't know exactly what that value is going to be. And then squared is represented with the number 2. A number less than 10, so that's subtraction. Half of n, of means times. A number subtracted from 19. Now notice on this one that the 19 is first, and then we subtract the number from that. Twice w, twice means to take it times 2. This one here says v divided by 3 is equal to 34. Another way that we might write this is like this. V divided by 3 is 34. All right, we have a few more here. X increased by 7. Now, increase by means to add. So we're going to take X, and we're going to add 7, and it says it is equal, so is equal to 80. Okay, our next one, the sum of 11. So if we have the sum of 11 and a number, that means we're going to be adding something together. So it's the sum of 11 and a number divided by 2. So that's this part here. And now notice it says is the same as 34. So is the same as 34 means that it's equal to. So the product of a number and 7. So we have 7 times n. And then it's increased by 18. Increased by means to add 18. And then again, is the same as means equals 102. So here's a few others. Quotient of k and 2. That means division. So quotient means division. Is greater than or equal. So that's this, 32. So our next one, half of r. Now another way to write that is to put r divided by 2. So you could also write this like that. Half of r, no less than, remember, means greater than or equal to. Number 12, r increased by 7. Increased by means to add is greater than or equal to 40. 10 less than n, so we're doing n, and then 10 less than that is less than 87. The product of t and 8, sometimes things are not written in the same order that we express them. We always put the number in front of the variable, and then it's greater than 29. And the last one on the screen, sum means to add, so x and 9, and then at most means less than or equal to 33. All right, we're just going to look through a few of these story problems. So the first story problem said Melinda has a total of 47 pages to read for AR. She reads 19 pages on Monday. How many does she have left? So if you think about this, we'd probably do subtraction. So when you write an equation for this, you're going to be thinking, well, the opposite of subtraction would be to add. So when we set up our initial equation, it's going to use that addition. So if we took whatever she read, say Monday plus Tuesday, that's going to be her total AR. So when we set this up, we know she read 19 pages on Monday. So we would take that and add that to however much she needed to read the next day, and that total would be 47. Go on to the next screen. So this one says to write an equation from the verbal models and solve. So it says 15 decreased by 6 times a number. Well, decreased by means to subtract 6 times a number, right there, 6n, is means equals -9. Now when we go to solve this, because it says to solve, so we've done a lot of equation work. So we're going to use that knowledge from that. We're going to get our -16n by itself. So I'm going to minus 15, minus 15. So we have -6n is -24. So then n, if we divide both sides by -6, would be +4. Go ahead and work this next one. It says 6 added to the quotient of a number in 3. So 6 added to the quotient of a number in 3 might look like that. And then is means equals 8. And then we could go ahead and solve. We would minus 6 from both sides first. We have n over 3 is 2. And then we multiply both sides by 3, so we get n is 6. So I think those are actually fairly easy to set up. This next one, I'm not going to go through and work every single one of these, but to give you an idea, to measure your heart rate, count the number of heartbeats n in 15 seconds. So you'd actually take your pulse for 15 seconds, then you're going to multiply whatever your heart rate is in beats per minute. So when we set up our equation, we would actually have 4 times h. So in that 15-second time frame, if you ended up with 8, you'd take 15 times 8 and then multiply that by 4. Now the reason you're going to multiply it by 4 is because in a clock, your clock is actually broke up into 4. When you look at a minute, this is a 15-second, another 15 seconds, another 15 seconds, another 15 seconds. So let's say that you take your heart rate and you end up with 8 beats per minute. And you actually have 4 of those within that hour time frame. Okay? So sometimes you have to calculate based on the things that you know at that time. So I'm going to look at one more. This one here says Sarah has $235 to spend on artwork for her apartment. The paintings she wants to buy are $61 each. Each is a key word. She has a coupon for $70 off. So that should be minus 70. Her total. How many paintings can she buy? So as we look here, we have the artwork. And we're going to take away however much the coupon is, because we don't have to pay for that. So that's a good thing. And then that's going to be our money that's spent. When we set this particular problem up, we have $61 that we have to pay. Remember, it said for each painting. So we have 61 times each of the paintings. We're going to subtract that $70 coupon, and we want that to equal $235. We definitely don't want it to go over that, because then she wouldn't have enough money.